Hello and welcome to this wonderful panel discussion. I'm very excited today. We have a powerhouse of speakers from the Data-Centric AI Forum at the end of April, at the end of March, my bad. Um, and today we're going to be discussing two very interrelated concepts, data centricity and as a means for artificial intelligence. You can't have one without the other. So, with that being said, today we have Daniel Taylor joining us. He's a semantic engineer. We have Jessica Talisman. She is information architect. We have Kurt Cagle. He's editor in chief of the Cagle Report, and we have Dr. Kusum Lata joining us from Sharda University. So, with that, can we tackle the concept of data centricity and just evaluate that on its own merit? Is it a useful concept? Is it a means to an end? What is your observation there?
According to my observation, because I have done the work in a text data. So if we everyone using ChatGPT or Perplexity, these large language model, and all these are based on the data. So if you say that what is data centric, so data centric is about like it is focusing on the data, whether your data is quality of data, or I can say the correct data, uh, we get quantity or data also, because if we have a large number of data, large data set, if we are training the model on the large data set and the correct data, then it will give the correct result. We can say the accuracy will be better.
Daniel?
Um, yeah, so I
The idea.
I occasionally lapse into daydreams in the realm of data centricity because it's such a multidimensional phenomena and space, um, and it's a fascinating time to be involved in all this stuff because we're really at this crux, the crack of the whip when it comes to the translation of data to information and the integrity of informational systems that are built out of these mosaics of whatever data we could put together over the last 30 or 50 or 100 years. We've built so much by accretion and by improvisation that we find ourselves about to put in the clutch and shift to another gear, and doing that requires a different level of understanding and connectivity and communicability in data. So it is a means to an end, but the end is a fundamentally different and more natural way of dealing with data and information.
I think
Jessica?
that's a pretty, yeah, thanks, Kurt. I think it's a pretty loaded term because one person's data centricity is another person's data centricity. The definitions may not match. I'm observing an instance of a property graph essentially being called a knowledge graph, understanding the differences between the different types of data structures. I do think that there's education out of the gate and how we can uh, suss out the best, extract the best results from an LLM. I think that one thing that's been agreed upon in this approach is that structured data is optimal. And that structured data being descriptive and contextualized is really important. And it representing or being able to parse and relate um, data from that LLM to uh, models, internal models, company models, domain specific models is really important. So it can be intricate. I was actually remembering conversations that were going on earlier and still are kind of going on, is the idea of semantic um, and what that means, which is an important part of data centricity. So semantic doesn't just mean applying a word to a table, a row, a column. It extends beyond that. So really trying to come up with one idea of data centricity, I do believe that shift and is happening, but it's it's by agreement on approaches and representation. of data so that it's both semantic and structured.
We had a bit of a pre-discussion before we went live, and there were a lot of very good points. I almost wish we had actually started at that point. But first of all, I find that we're at a really interesting standpoint, because I can tell someone today that I'm an ontologist, and they will look at me and say, "Oh, you don't cure cancer." And I said, "Well, I do, but that's not my job title. That's that, that." um, uh, the I think what's happened is that we are in the process now. We've basically shifted away, and this is kind of taking some of the discussion we've had earlier. We're shifting away from an application centric view of problems. Those within the application centric way, you basically are saying, I'm wanting to build information for you. I'm wanting to create these great tools that allow it, and the data is very secondary in that approach. It's something that most programmers, when they are looking at the problem of data, they look at it as an inconvenience, because they want to be able to define their data space internally. They want to be able to say, this is the structure I want to be able to deal with, because it solves my immediate problem in being able to make this application work. And that's fine if you happen to be the only programmer working within an organization. But the moment that you have more than two or more than one programmer dealing with a problem, then you basically begin to get into questions of interoperability. How do you basically say that that what I'm talking about, my definition of things and how they relate at a structural programmatic level, is going to be useful to you when you're dealing with your particular program that may take data from mine? But I don't want, as a designer, as someone, I don't want to basically having to manually type in numeric keys from a database from some previous program to use as an identifier, um, uh, because that's the only way that I can get reference back to a particular database and the data that's contained within it. So there is a key part of interoperability that comes when you basically say, look, here is the model that we as an organization are going to utilize. And that model is not necessarily an industry model. It may be based on it, but it's basically something that does define the organization, because there is a question of scope as to when you get too big about how generalized or how specific you can get your model to be able to work. But if you have that model in place, if everyone basically agrees, look, this is not only the term that you're using, but here's the structure that's associated with it, then that actually will help facilitate application development, because you're not having to spend all that time essentially doing that process manually, but ahead of time. It can be inconvenient if you're a programmer, because, well, I can't go in and define these structures that I'm looking at myself and expect to be able to work with it in my terms. But from an organizational standpoint, it's a huge win. There's trade-offs. There's always trade-offs, but that thinking of moving around a data-centric modality where your organization has basically agreed upon terminology, has agreed upon structure, has agreed upon protocol, is so much more important than satisfying the ego or facilitating the I can get out of here by 5 o'clock mentality of being a programmer. And, as a programmer, that may sound like heresy, but I really believe it to be true.
I'm going to make a point on that. So we have language and we have ontologies as some idea, as some standard of knowledge. They are sort of stamps of ideas, symbols, experiences. Why are they important as a standard between people and between humans and machines at large?
I mean, taking care to represent for machine readability and human readability, I think is included in my definition of interoperability as well, to Kurt's point. So it matters because that machine translation is the essence of how a part of how LLMs work, but part of our interaction also with those LLMs and how we represent the world. Our common understanding, how we reach agreements, to Kurt's point on structuring and having agreements around, what, for example, we call things or how we represent things or how we choose to stand up, for example, a knowledge graph and connect that to an LLM. It's paramount that to those agreements that we support that understanding, machine and human understanding of the data.
I think it's an interesting time right now because we've gotten to a point where the machine interpretability has raced forward from where it was 10 or 15 years ago. That for the longest time, in order to make things machines could read, we had to make them borderline impossible for humans to read. That something that was supposed to be human and machine readable had to err on the side of machine readability so that it would work for anything, so that it would be usable. But that has led to ways of representing that information that humans have a hard time interacting with. And now that we have more enabling technologies that can help facilitate that translation, it should be less daunting to engage other human beings in creating these kind of structures, these kind of structured information and building ontologies, and being able to look over them together and revise them and find problems with them and do all the things that we do with information. Yeah, so we can be more human friendly now because we've gotten the machines to have much better abilities at reading. So things that were necessary 30 years ago aren't necessarily the case today.
Yeah. If I can jump in, the I think the thing to keep in mind with LLMs is that LLMs are large language models or language learning models, which I find is a much better description because it gets us away from talking about large versus small. But if you have a language learning model, the idea behind that or the interaction with that is something that when you specify or when you're dealing with the information that comes out, what you have is, as Daniel rightly pointed out, it's much more human friendly, but it's not necessarily much more computer friendly in that regard because you're losing information. It's lossy. And so one of the big aspects that I've been working with a lot has been to say, as a first get out, when I'm building LLMs, when I am, doing the training models, first thing I do, especially for smaller corporate LLMs where you're talking about an organization, is I say, let's run through before you put anything else in your system, run through about 4 or 5 times. You give a significant amount of weight to your internal ontology. Because if you think about it, what an LLM basically represents information as a fractal. It's a pretty fractal. It's a fun thing to look at from okay, I have a 32,000 dimensional space here, and turn that into something that has some kind of internal representation. But one of the things that I've found over the years is that a fractal, the presence of, a fractal basically appears whenever you have a large network. The two are very fundamentally connected, and there is a network of concepts that exists within a language model. If you can essentially say out the gate, the first thing that you're going to learn is our ontology, our structures, how we deal with information, and even better, how we also deal with concepts that come in a priori, then you've gone a long way to basically saying any document that comes in is going to build upon that fractal, and essentially build out a structure that is much more friendly to the kind of logical reasoning that you're trying to do. Now, you can do other things. You can basically put that ontology in after the fact and be able to get something that's useful. But if you can train it up early, if you can get it early enough in the training cycle, that makes a huge difference in terms of how your data gets pushed back to you, because it means that it's not going to spend a lot of time in computation. It
Yeah.
means that your data is already at least partially pre-configured, which means that if you do then go back and remind it that the ontology exists, it's going to be a lot more amenable to be able to say, give me this as a full structure according to this ontology. That what you'll get back is actually meaningful.
Yeah.
And that
I,
becomes very important when you start talking about hallucinations.
I like to say wandering the hallways, Kurt. Your model will be.
Yes, exactly.
Yeah. Yeah.
Um, Kusum, would you like to make a point to that?
As every point they have covered, I agree with them. Because if the whatever the data we are creating, we it is like in that format, or we are representing in such a format so that the and like if I have created a one data, so other person can be able to understand data, what purpose the data is created, and the same as that will be that will be now we have given as input to like a LLM. So we should represent the data in a way that also that machine can be able to understand.
The ultimate objective here is not human to machine interaction
Mhm.
or engagement, but it's human to human through machines
Yes.
to enable a decentralized way of representing an idea, a federated understanding, right? That, I guess, that's a better way of representing that
Yeah.
idea.
Yeah.
So where do we start with this intentional arrangement of a computerized system? Where do we start with architecting this common understanding, common worldview that is multilingual agnostic? I mean, Daniel is in Chicago and they call soda pop over there. You know, we call soda
Not here, but point
no.
taken. Point taken.
Well, soda in English has interchangeable terms. In Spanish, we call it gaseosa. So how do we reason and negotiate with these multitude of meanings?
I, th- if I may, I think there's a little bit of challenge that's even implicit in your question, and it's kind of an echo of why the idea of data centricity is important. And it revolves around the challenge of even describing a data-centric construct. Is it a system? Is it an information world? We're so used to thinking of a computer system, but when I think about one of the important principles that defines data centricity, to me, it's about autonomy and ownership of your own data as an organization or an enterprise. And it's easy to see how the world of engaging with AAA large language models could risk putting you in that same application silo where you've put all your eggs in one basket, and when OpenAI disappears, how screwed are you going to be, right? So as an approach to that, I've been trying to think about data-centric data products that organizations or people can make that will empower them to build in an AI landscape. For instance, turning your documentation into structured or semi-structured data is makes what you already have into something that can be used to train another model. And whether from one case to another you use that to fine tune a model that somebody else has built, or to build your own smaller scale model, or in what turns out to be one of the for me inspiring quirks of the world of these models, is that you can combine them and melt them down and put them together, and you could genuinely build your own model based entirely on your own ontology and your own concepts, and train that in conjunction with, say, an open source model that doesn't require as much horsepower to run as ChatGPT, but brings along some general reasoning and some, wider functionalities that by having your own structured knowledge and your own ontologies and your own knowledge graphs, you have the ability to engage with a whole landscape of AI, from platforms to homebrew projects and things like that. And if you start with that gold quality information and structured data to the extent that you know what it means, that it's consistent across your organization, all these magic future things that are on the horizon turn out to be things you can walk right up to and say, this is what I know, this is what I care about. How do we make this work with, you know, Claude 4 or Chat GPT 5 or whatever's coming next after those. So that idea of durable data products or informational products that arise from your organization, even before trying to say, do we build a large language model? Do we fine tune something that exists? We say, do we have a knowledge graph? Do we have
Yeah.
structure to our
Yep.
information? Can we take our documentation and say, this is how you navigate it? This is how you know what it refers to. Because if you've got that, all the other artificial intelligence stuff, people who know more than me are busy doing that. So I have to make sure what I believe and know and understand makes clear sense. So when the day comes, I can say, here's the information I care about. Help me build it into something
There's
magic.
there's a
Yeah.
there's a combination of a couple of things. Sorry to drop in there.
Oh,
There's some interesting developments going on right now in the in that particular space, in the AI space. We're seeing this growth of mixture of experts, which basically is a way of saying, hey, look, we're federating data, or we're distributing our intelligences. And everyone is in the machine learning space is going, wow, what a novel concept. And everyone in the ontology space is going, so we've been doing it for 30 years. But realistically, I do a lot of work in with diffusion, so stable diffusion and a lot of the things that are used for visual media, like Dolly and other things like that. And they're similar. They're not quite the same thing. But one of the concepts that kind of emerged last year with the diffusion model is a concept called LoRa. And I don't remember the exact expansion of the acronym, but the idea behind it is that a LoRa is effectively a lens. What it amounts to is it's essentially a much smaller weight. Usually about 1,000th of the size of many of these bigger models. That you can apply to a general model that essentially takes that lens and allows you to essentially filter what you're getting out, so that the transformations that you're doing, it's essentially a high dimensional matrix tensor product, or tensor product, that gives you the ability to say, these are the things that are actually more important. And these are how I want to be able to express it. From a LoRa standpoint, I can say for a general model, okay, I'm going to optimize here so that I have more race cars, and race cars get a much better resolution than, say, people. And for this image, I can use those race cars, but I can then take that product and I can say, okay, now I need to concentrate on people, and I'll use these images and the data that comes out of those as kind of the next stage to be able to say race cars and people. And so that specialization, that ability to put lenses on models, is actually a pretty key one, coupled with this notion of saying, look, knowledge is deep. Knowledge is very deep. We can't hope to realistically capture everything without essentially scraping the entire internet. And as we all know, that's causing problems. But if you can then say that there are ways of using, these LoRa's, using things like retrieval augmented generation, or RAGs, to also basically pull in information from external sources, that goes a long way towards being able to say, look, the data that we're working with doesn't have to reside in a single point. It's in fact distributed. It's so there's the tension right now, because I think that everyone in the neural net community wants everything to be an LLM. But the vast majority, 99.995% of all information that's out there right now, is not in an LLM, will never be in an LLM, because an LLM, for all of its power, has a lot of problems.
Yeah.
And we're all beginning to come to the understanding of what those problems are. They're very, very convenient. They're really good at natural language processing. But at the end of the day, when you're talking about what an LLM does, you realize that it really doesn't have any internal conception of how things relate to other things, other than what it can determine by word order coming from multiple documents.
Yeah.
And so because of that, we're having to rethink the whole notion of, well, what do we mean by structured data?
Yeah.
And what do we mean by we've lost a certain amount in that fractal structure that we can take back, but we have to understand in the first place that these are not databases. They are, there's something else, and we're still trying to figure out what that something else is. There are things that are very good at essentially trying to put together based upon enough inferencing that if you have a large enough data set of a particular type, it'll tell you the answers that you're looking for. But they're not databases. And I think that's one of the key things with the knowledge graph, is that I can give it a key or a couple of keys. I can basically say, here is a term, here is a relationship. Now find me all things for which this is true. And it will do so, and it will do so consistently. Now, downside to that is a knowledge graph is hard to query. We understand, that if I talk about this, I have to use a certain language. I have to use Sparkle. I have to use GraphQL. I have to use GQL. I have to use Open Cipher. I mean, there's a lot of different tools that I can use, but those are all specialist terms. And it'd be really nice if we could basically get our knowledge graphs talking to our LLMs to the point where we can say, LLM, you're responsible for giving me a good query that will get me the information that I want. But to have that happen, you have to basically let the LLM know what the ontology is, what at least what the structure is, what the schema is, that you're working with. And I've talked too long, so I'll give up.
I think the contextualization piece is key.
Yep.
And that's something that happens with relationships and with attributes and properties. It has to break out of the construct of it simply giving attributes to data points. It's not an enumeration of. There's more detail and nuances, I think, that can seem pretty complex to most. The one question I have is, it seems like with LLMs, or the advent of mainstreamed LLMs, is that our mental models all of a sudden shifted from where human cognition involves that relationship and contextualization. That's how our working memory works, and that's how our cognitive modeling works. Being able to shape knowledge in that same way with the contextualization, so that we could garner or be able to harness the power of LLMs with graphs, is fundamental, I think, to how we structure data. Structuring it to match human cognition is critical. Where we've departed from that model, I see a lot of look at, vector databases. All of those things are great. Vector databases, NLP, and trying to find these shortcuts to leverage the value. I don't think there's any replacement for shaping information to become knowledge. It's, RAG's the closest perhaps, but I find, oftentimes, we try to model the universe rather than sticking to our domains or really trying to specify what's unique and important to a domain or business. I think that's really critical, that there's a thoughtful process to that, to shaping our data, for caring for data. So
like as when we are creating the data, I think there's one requirement for like if we want to we check the data is correct or not. Like if we can create a data for a different domains for a different task, so for that purpose we need just like a subject expert also. Like if the girl has said that like there is a relationship between these entities, so for finding the relationship between the two entities we need some expert of or we can say the like knowledge of the person or the human also, like who has the knowledge about that particular subject or particular domain.
I think that's an important thing to keep in mind, because one of the fundamental perils in this kind of thing is either premature or incorrect abstraction, right? Where you think you know what somebody's describing, so you decide that that is referring to a scheme you're familiar with reification that you're familiar with, and it turns out that within the specific context of that domain, specific terms are used for a reason, right? There's implicit knowledge in a domain that will be lost when it's translated into structured information. That's the nature of information and abstraction. And you lose, in some sense, the thing in between the levels you're reifying. So if you pick the wrong levels of granularity in your representation of the information, then you run the risk of setting yourself up for future perils or for losing something significant. So there's an inherent tension between external or sort of general level ontologies and structures of meaning that make it possible to communicate broadly with other organizations, and then the idiosyncratic context specific ways we use language to do whatever it is our enterprises are doing. And at the same time, we don't want to start from scratch and reinvent the wheel every time we face a new project, but we also can't assume that the project we're facing lines up with this external ontology that we need to be able to plug into. And so, you could, Jessica was talking about this earlier, coming into situations where someone has assumed this global ontology is applicable for a project, and you end up with all this noise of a bunch of factors that have nothing to do with what's going on, and it takes you longer to weave back out the important parts than it would have to just get them in the right place in the first place. So that constant tension between standardization and specificity, is tricky to navigate. But I'm so encouraged by the fact that large language models turn out to be good at reading knowledge graphs. That every week I'll see a new set of papers coming out that demonstrate that adding knowledge graphs to the environment of large language models improves every metric across the board.
Yeah. If I can jump in for just a second, I wanted to actually bring up a definition that Daniel pointed out that may not be familiar to our readers or our viewers. Reification. Reification is basically this concept where you say, I have an assertion that I'm making, and I'm going to then make an assertion about that assertion. I'm a member of the RDF Star Working Group, and everything that we deal with right now is essentially about what exactly reification is and how we want to be able to express it within RDF. But the idea behind this is actually pretty critical because it gets into the question of when you're talking about reification, are you actually talking about reification, or are you talking about an aspect of the model that hasn't been modeled yet? A good example of that is that I can talk about sets of airports, and I can actually use the notion of reification to be able to say, I have an assertion about two airports that exist. So airport one has a route to airport two. However, that particular statement, that particular assertion, has a wealth of information that gets associated with it. And you can reify that. You can say that statement that I've made, I can talk about things like how far is it? What airlines run across it? There's a lot of information there. The question then becomes, is that reification something that I actually want to capture in the model that I'm building itself? And this is one of the complexities that you deal with information, is that you often have this. At this point, I can say, well, maybe I needed to start talking about a route as a particular class of entities that is distinct from airports and isn't necessarily physical, isn't necessarily an entity in that regard. But it is something that is important to the model because it carries so much information. And so, when as an ontologist or as someone who's a knowledge engineer who's working on the domain, one of the big questions then becomes, do I have these reifications that keep showing up that actually represents that I don't have a concept in my model yet to be able to facilitate that? And I think maybe the next stage of this is that at some point, we will get to a stage where we've got models or LLMs or something, their next generation, something that's a little bit more recursive, that can basically say, oh, look, you're talking about reifications. Maybe we need to revise our model and change that. And that's a really interesting idea because at that point, you're learning. At that point, your model is actually actively learning and being able to create associations based upon this notion of saying, I'm looking at these data points and I'm suddenly discovering, oh, there's different ways of thinking about it. Now, before we talked about, before we started, Jessica brought up the distinctions on property graphs. And this is actually something that's raging, right now in the RDF Star working group, because one of the mandates for that is essentially harmonization between RDF and property graphs. And one of the big distinctions that you have between the two is that most property graphs, and I'm going to specifically call out Neo4j, but most property graphs are essentially built with this notion of saying, I have two objects and I have an edge. And that edge is essentially a connection that has a whole bunch of additional properties that are defined, specifically literals that are defined that identify certain sets of data. Now, the problem that you run into right now is that those in the edge space that we're talking about, the structures are actually a little bit different. If you can basically take that and model it and say, wait a second, what we're talking about here, there's a data model aspect to it that I can express in RDF that gets very difficult to express in property graphs. Property graphs seem to be simpler, but they're actually more complex entities that hide a lot of the simplicity in terms of their own intrinsic structure. And so, this kind of gets back to this whole question of trade-off about, yes, you need consistency, but you also need to recognize that as you are working with information, what you know about the space is in fact growing in terms of identifying not only new data coming in, but also new ways of constructing the model to be able to represent that data. And that's a really novel concept right now in the semantic world, because we don't do that very well just yet. And we're beginning to recognize the need for it.
we
So
have a comment from Erin Willman, and she says, meanwhile, many organizations overlook the operational efficiencies to be gained by adopting centralized data like DNB SIC codes. A little governance can go a long way. And I think that goes on to the next topic of discussion, which is this idea or this inhibitor of adopting standards. Why aren't we adopting standards? Why is it so difficult? There are these standards that have been around for some time now, and people would rather just reinvent the wheel or create their own language. They don't want to bend the knee, or in a more polite way, they don't want to adopt this language that solves the problems that they're trying to solve on their own. So how do we navigate that, and what are the obstacles in that? Oh, you're on mute.
It's a tricky space. Absolutely. The idea of standards and protocols, and we were talking before we went live about standards and protocols, that there's a reason for them existing, and a lot of the standards to build to spec and following those standards and protocols is takes longer, and there's more care that has to go into the process of building. It doesn't go at the speed of light or the speed of data engineering. There's a different cadence that's set. So expectations, business expectations, automation, those sorts of questions, I think definitely enter the enterprise sphere of that value proposition. I think that something that I've been thinking about lately is the precursor to RDF, and you can this could be argued, but RDA, resource descriptive access, which is fundamental to bibliographic records. The idea of describing and standardizing records and maintaining inheritance and provenance and all of those topics that are coming up in LLMs with big question marks in our heads of how do we maintain copyright and provenance and care for artists and writers while still extracting the goodness of these models. I think there's a lot to be learned from the library and information science world in terms of how it's been standardized and how that can be leveraged, because essentially Library of Congress, FAST, BIAF, OCLC, those all exist as knowledge graphs to some extent. Those bibliographic records and inheritance, they are maintained and successfully with machine translation into cross languages and environments. So I think that standard, if we were to take a lesson from something that exists in the real world, that would be a great lesson to take from the real world, is how we represent things in the library and information space and how that translates into a graph shape.
Yeah, the librarians have a lot to tell us. I mean, I've worked for the library, or with the Library of Congress. I haven't worked for them, but I have worked with the Library of Congress, and a lot of other organizational bodies like that. And typically, the librarians are the ones who understand both the taxonomy and, in many cases, also understand the ontologies. They don't necessarily know they do. But that's I've worked with many librarian groups over the years, and every single one of them is basically doing exactly what you're talking about here.
Exactly.
They're saying we have records about things, which is that first order reification we were talking about earlier. But that process of basically organizing and classifying information is a very, very necessary part of any organizational's DNA. And we don't do it very well. We've been working with it for a while. Obviously, in many respects, I think what the LLMs have done is forced us to actually rethink a lot of the assumptions that we on the data side, on the semantic side, have made about how exactly we are representing that data. But it also means that we're in the process of saying, okay, what do we mean by governance? What do we mean by provenance? How do we
Mm-hmm.
capture provenance? What's the mechanism? What's the standard? There are some very good ones out there that aren't being utilized because nobody knows about them,
Yes.
unless you happen to be a semanticist. And Bravo is
Mm-hmm.
is
Yes.
one that immediately jumps to mind as being
Mm-hmm.
very much provenance centric.
Mm-hmm.
So we have these tools, but essentially it becomes a question of developing best practices and simply letting people know that these things exist can
Exist.
go a long way towards being able to facilitate this kind of adoption.
I think there's a question of incentives too that
Hmm.
that goes to what you're talking about, that in some domains the idea of a knowledge graph ontology to facilitate interoperability and communication is absolutely essential, right? You allow
Mm-hmm.
thousands of people researching genetics and proteins and pharmaceuticals to communicate about the same stuff, to share data without having to stop to interpret. Or in system engineering, if you're building a satellite that takes 60 different contractors manufacturing things to exactly the right specifications, you can't be ambiguous about any of this stuff. But
Hmm.
if you're a small business or a medium-sized business or even a large company, the idea that your information structures would make sense to the outside world isn't intuitively a benefit to you, or it may not be. We think about, well, if it's clear where all my information is, and somebody can walk right in and take it. We have this weird kind of backwards cryptography through poor organization. And I think um, selling enterprise level the benefits that come with standardization in terms of making application development easier, making collaboration and automation and optimization between different platforms easier. That there are things that at the enterprise level people aren't necessarily so used to wanting to have to comply
Mm-hmm.
with. You say, here's a structure, you have to make sure your data matches that. But another encouraging thing about the beauty of knowledge graphs is the ability to use knowledge graphs to translate from one scheme to another, right? That people in the biosciences don't necessarily have a single universal ontology. There might be one ontology that is shared among people working in brain chemistry and gut bacteria and protein synthesis, and they've all agreed on this particular ontology that gives them great utility, but it's specific in a way that might not apply to a different domain. And the idea that your knowledge graph structure, your information structure, can communicate at a native level with different ontologies by way of translation, um, kind of gives us a way to moderate that, to say this universal ontology is really useful, so we use it for all this stuff. There's this like dialect, almost like a case specific ontology that we are sharing with other people in our domain, and we can use that as
Mm-hmm.
well. And that there's not, you don't have to pick the only one you're going to use for the rest of the time you're building. I mean, obviously you have to pick one and be consistent, but if the outside ontology changes in some way that you know you don't want to play with anymore, if somebody comes up with a better one or something like that, um, yeah, being able to navigate that space of where the names for our things connect to the names of other people's things is the meat and potatoes of all this knowledge graph stuff.
Yeah.
Yes. I was
Um,
going to say this like goes in again to shadow from the library world. This is a domain that's been around for a while called scholarly communication, which is essentially that principle of, that instead of repeating each other's research or overlapping, that by way of sharing and breaking down the paywalls, and the publish or perish paradigm, that that by sharing that we can actually advance innovation. So to that point, sorry, Kurt.
oh, no, no, no. I
But
think
yeah.
it's a very good point. Um, Additionally to that, one of the aspects that we are looking at is transformation. And this is something that often gets lost
Mhm.
in all this discussion. There are tools, many tools actually, that allow us to do translation or
Yeah.
transformation from one schema to another. And in many respects, I think that's actually a very powerful paradigm, in that if you have consistent, if you have a consistent internal ontology, where internal is internal to your group, but you still need to be able to communicate with the outside world in some respect, then that ability to be able to say, look, I can create a transformation, whether it's Sparkle Update, whether it's, there's Tarkle, there's, many similar tools out there that are specifically designed for the purpose of saying, if I have RDF, a little harder to do with property graphs, but it can be done. But if I have RDF, I can basically take my representations, and when you make a request against it, I can transform yours to mine. And if we've done that process once, then we've done that process forever. Is if we agree upon protocols saying, okay, I have a transformation that exists between A and B, and anytime I have A, I've already done the work once. I don't have to do it again to make that transformation. It's still work. It's still something that needs to be done. It needs to be calculated into the overall complexity of building a large scale system. But that work that you're talking about, that transformation work, is really, to me, the nut and potatoes of what an ontologist should be thinking
Yes.
about. How do I map from one to the other? And is this a map that's worth building? If it is, then build it. Those maps, I think, are in many respects the glue that kind of holds us together, because we're not all going to agree to the same ontology. We're not all going to, my company has its own particular requirements. Your company has its own particular requirements. We can either agree upon standardization, which may or may not happen, or we can basically agree upon the mechanisms for transformation. And I suspect that the latter is actually going to end up becoming more common, especially if you can get an LLM of some sort to do the translation for you, because that's what they're very good at, is
They are good at
building
that.
those kinds of transformational maps.
Yeah.
In the frame of this discussion, I think we've made an assumption around standards based on things that are reflected all around the world. If we talk about carpentry, we're going to talk about wood. We're going to talk about the carpenter's tools, the methodologies that they use to construct wooden objects. What about in circumstances where knowledge is not universally found everywhere? I mean, you have some underlying mechanisms like in linguistics where you have grammar, you have nouns, adjectives, you have these essential elements. How do you preserve an a language that may not be accessible? How do you preserve something that doesn't have a subject matter expert around, or not many resources that allow you to find the pieces for that broken puzzle? And I'll pass the mic to Kusum because she did some work around that, so maybe she can shed some light.
You were saying that which is having less resources for a particular, if we say that for a particular language, again the same thing as because when you are developing any resources or a data set for a particular, if we say the large language model, if we are developing a large language model for a low resource language, then again we required uh, the again that language expert, because that language expert has the knowledge of a structure of that grammar that for that particular language. As like if in India there are a lot of regional languages are here. There is a one language that is for one state, which is Odia language. So in the Odia language there is a different way of writing a one sentence. Like if, as we say that in English, we'll be following the SOV, the subject object verb structure of the sentences. That may be the different in the Odia. Like in Hindi there is a different, there is a flexible order. We can use verb first, then object. We can use object first, then verb. Like SOV or SVO format, we can use different in Hindi because it is a flexible language, and the English is a fixed ordered, we can say fixed word order languages, and Odia have a different word order language. So for that particular, also we required the language expert person, so that when we are developing any data set or any tool, developing the tool for particular that language, then we we have to create data in a such a way that so that that model will be able to understand the structure of that text. We can say that the structure of a language. Well, as we say, we are saying that we have a machine translation tools are right now, the Google Translator. So how they are converting one text which is in a one language to other language. Like if we have a text in a French, we can convert it into a Hindi. So because they have given the data in a parallel corpus, we can say that we have the text or sentences in a French, and parallelly we have the representative in a Hindi, we can say. We have trained that, and they have trained the model on that data set so that they're able to understand. The context understanding also they have, in which context they have uh, like they are saying particular sentence. Sometime what I have observed, like if we are converting one sentences, let us say in Hindi, and we are one document and converting into in English, so there's sometime the meaning will be changed. So I think in a model, whether it is a translation model, whether it is a large language model like a chat GPT, that there is, we have to give, we have to improve in the context understanding concept.
With to tie off the panel discussion, I wanted to go back to one of the elements that we were discussing in the warm up session, and that was this concept of care and cure. And I'll give it to Jessica to explain her thoughts around that, and then we can riff off and tie it off in a nice,
Right.
graceful manner.
So before we came live, we were discussing the idea of caring for data, and that has to do with intentional arrangement and how we choose to structure our data, whether adopting some common model that exists already or actually curating to be specific to our domain or our organization. The process, the steps, means to an end that we choose to take in an organization. That's another part or piece. So setting up the correct foundation when building a graph, with the end goal in mind. And not to steal the thunder, but Kurt brought up a very good point, and I'm going to pass it off to you, Kurt.
Okay. Yeah, to carry this on from Jessica's comment, and I think it's a great one. I made the notion, or I made the observation, that when we're talking about care, the Latin word for care is cura, which basically is the root for words like curate. That there's a lot there. I mean, the notion of basically, looking at curation as the process of caring for data. Looking at I mean, we talk about governance, but governance is essentially curation. It is the process of essentially saying, is that data clean? Do we know the origin of that data? Do we understand the reliability of that data? Is the data something that we have a right to be able to utilize? Because not all data is. That's one of the big struggles that we run into when we start talking about areas like copyright. Copyright is at its core a curational aspect. It's a question of saying, we don't have provenance, or when someone creates something, they should be in some manner or other compensated for that, because that creation act is essentially something that we recognize has value. And so when you talk about curation in that regard, it's basically a question then of saying, we have a value proposition that is unique in the intellectual property space, or in the knowledge domain space, where we recognize that these things, even though they don't have physical immediate physical applicability, nonetheless have value and bring value to the overall proposition. So when you're talking about curation, you're basically talking about the way of adding value in your organization and of essentially accounting for that value to the various stakeholders that are going to be utilizing it. So yes, I mean, I think that value and intellectual property rights and privacy and all these other aspects really come down to the fact that we do recognize that these intangible things that we're dealing with do have value in the physical world and need to be treated accordingly. You talk about, okay, there is someone who is basically responsible for managing where all your fleet vehicles are in say a rental car business. Well, it's the same thing. You have someone that is responsible for the care and upkeep of the language that you're using. And that person plays as much of a role in your organization, or should, as the person who's basically telling you, where are my vehicles at the present time? But we spend a lot more time concentrating on that latter piece because we're still coming to grips with what the value of information really is.
Yeah.
I think Jessica had a couple of important comments on the same the idea of the slower sort of cadence of doing this ontological work, um, and the idea of intention and intentionality, that there's, from a development perspective, you quickly end up in a tension between expediency and that sort of care and intention. And it's always a matter of, do you have the time and the resources to do it right or do it now? You have to kind of negotiate that tension. And for me, another one of the fundamental principles of this data centricity in the more kind of philosophical sense is not duplicating your own effort, right? Like a touch at once kind of prospect, that if you've answered these questions, you don't have to keep coming back to them. And so if the complaint is that it's too much time and bother to answer these questions, the answer isn't that it just takes longer, but that we're answering them so that we don't have to answer them again next week and next month and 3 years from now. That the deliberate, intentional care we put into how we describe and talk about the things that matter to us, the things we have data about. I mean, that's why we have data about them in the first place, because we care about them and they mean something to us. And that answering those questions at the level of language and concept isn't separate from data. It's not separate from software engineering. It's not separate from data engineering. It is how we as humans make all that stuff make sense together, and it is not always fast or easy, and that doesn't make it any less important. um, so yeah, being in a position to say, this is slow work and important work, and you'll thank me later, is is an interesting
Yeah.
professional and philosophical ground to stake.
Kusum, do you have any last words?
As the all the points as said by three of them, that when we are creating the data, I think the data should be reliable. I mean, we are giving the correct data or not. If you are giving the incorrect data, then your model or whatever the result is will be wrong always.
Okay. Well, thank you for that, and thank you all for joining this lovely panel discussion. My fault. That was my fault, Kurt. I conflated you guys talking about care, cure, curate. My bad. But thank you guys for joining us with this powerhouse of brainiacs and discussing these very important terminologies and sort of breaking down the walls around this interdisciplinary pursuit of knowledge. It's not easy, and nobody expects it to be easy. I think that's kind of the point of this conversation. There's scope, there's complexity. You have to learn new concept, new ideas, new language, and then you have to try to reason that with what other people are trying to do, which is solve the forever problem, the standards. Um, yeah.
That's
Thanks.
great. Thank you.
Thank you.
Yeah.
It's a great conversation, guys.
Yeah, it was a pleasure. Thanks so much.
Thanks.
Thank you. Thank you so much.